Now that we have seen real numbers as exponents, we can introduce the concept of an exponential function and what the graph of an exponential function looks like. So, an exponential function is any function of the form c a to the x, where c is a non-zero number and a is positive and not 1. The domain of this function is all real numbers. A, the base of our exponential function, is called the growth factor, and c is the initial value because if x equals 0, then a to the x would be 1, and therefore f of 0 would just be c. So what does the graph of an exponential function look like? Well, we said that a must be positive and a cannot be 1. So there are two possibilities. Either a will be greater than 1 or a will be less than 1. So let's look at a is greater than 1. If a is greater than 1, then our function is increasing. Notice the domain is still all real numbers, and the range is going to be from 0 on, and we do not include 0, and there is a horizontal asymptote of the x-axis. So the horizontal asymptote is written as an equation, y equals 0. There are three key points. -1, if we substitute in, will be a to the -1, which is 1 over a. A to the 0 is 1, and 1 will yield a to the first, which is just a. So we can see those 3 points. So we are increasing, and we see those 3 points. Now what happens if a is less than 1? It still has to be positive. So a will be between 0 and 1. If that's the case, the domain and the range and the horizontal asymptote stay the same, and the key points are the same, except since a is less than 1, 1 over a will be bigger than 1. So 1 over a will be higher. 0 still yields 1, and 1 will yield a still, but it's going to be smaller because a is less than 1. So let's take a look at an example. So f of x equals 4 minus 2 raised to the 3 plus x. So let's rewrite this. This is -2 raised to the 3x plus 6, then add 4. If it helps, this is the same thing as -1 times 2 raised to the 3x plus 6 plus 4. So we have -1 times 2. I'm going to have to factor that 3 out of the exponent. So our parent function from our library of functions is y equals 2 to the x, which is increasing. Now that function will have the key points of 0, 1, 1, 2, and then -1, 1/2. So this is our parent function. Now what are the transformations that take place? We have the -1, we have the 3, we have the addition of 2, and we have the 4. So let's deal with the horizontal transformations first. We have the 3 and the +2. So the 3 corresponds to a compression horizontally, and the 2 corresponds to a shift left 2 units. So remember, order matters. So we compress by a factor of 3, actually by a factor of 1/3, we would say. Then we move left 2 units, and now the -1 means that we are going to reflect it and that's a reflection about the x-axis. It's a vertical reflection. And then the addition of 4 means we're going to move it up 4 units. Now, let's think about the domain. None of these affect the domain. So the domain will be negative infinity to infinity. Let's move our horizontal asymptote. Compression will not move the horizontal asymptote. Our left of 2 units will not move it. A reflection about the x-axis will not move a horizontal asymptote, but moving it up 4 will. So let's move it up 4. So instead of the x-axis, we have a horizontal asymptote of y equals 4. So horizontal asymptote, y equals 4. Now let's think about our key points. We had these 3 key points. So instead of the point 0, 1, we'll compress that horizontally, and I did not say that. That needs to say horizontal. Compress horizontal by a factor of 1/3. So compressing this point horizontally toward the y-axis does not change it. Then we move it left 2. Then we will reflect it about the x-axis. And then we will move it up 4. So we will land at negative 2, 3. Now, let's look at the point 1, 2. If we shrink that or compress that by a factor of 1/3 toward the y-axis, so compressing it horizontally, it will be at 1/3, 2. So 1/3, 2, moved left 2. Now let's reflect it about the x-axis. So instead of being positive 2, we will be at negative 2. And then we'll move it up 4. And then the point negative 1, 1/2, we will compress by a factor of 1/3, so that will bring it closer to the y-axis. So we are really at negative 1/3, 1/2. Let's move that left 2. So we're just under negative 2. We're at negative 2 1/3, 1/2. Let's move that, or let's reflect that about the x-axis. So now we'll be at negative 1/2. Then we'll move it up 4 units. So 1, 2, 3, 4. So we will be at negative 2 1/3, 3 1/2. So let's approach our horizontal asymptote. And you'll notice we are told to find the y-intercept. So let's go ahead and find the y-intercept. The y-intercept, if we plug in 0, f of 0 would equal 4 minus 2 raised to the 6th. That's 4 minus 64, which is negative 60, which is not going to fit on the graph. But it will cross the y-axis. So there's one thing left to find, and that's the range. And the range will be from negative infinity all the way to positive 4. So negative infinity to positive 4. Don't include the 4. And there is the graph. The domain, the range, the horizontal asymptote, and the y-intercept.